the question I want to raise is a more general one, which is economic growth sustainable? And the role of technological progress or innovation in economic growth has been growing in the last 200 years. And it is the main reason why economic growth has turned out to be not a blip or a temporary thing, but actually sustainable. And the reason is that if you have an economy grow because of accumulation of capital, for instance, so you invest a lot in infrastructure and in capital goods, economics teaches us that this will eventually run into diminishing returns. That is not the case, however, for technological change. Technological change, as far as we can tell, is not running out of ideas. It is not running out of dynamism. And that, I think, is something that we have learned during the last 100 or 150 years. Now, this is not an uncontroversial position. There are people in my profession, as well as outside it, who basically claim that the low-hanging fruits of innovation have been picked. I mean, after all, we have invented air conditioning, we have invented indoor plumbing, we have invented nuclear reactors. We cannot invent them again, by definition. Is it possible that we eventually will run out of ideas? And I'm going to try to convince you that that is not the case. And the reason that I'm making this argument is precisely on the topic of what this conference is all about. And so, if you ask the question, when does science advance? One of the factors that drive science is technology. That is to say, the tools and instruments that scientists have to make discoveries. And one of the reasons why Greek and Hellenistic science, despite the genius of their scientists, really did not make nearly as much progress as they could have, is because they did not have advanced tools and instruments. In fact, they didn't even look for them. They were just reasoning very cleverly, but they did not have the kind of tools that emerged during the scientific revolution. And so the most famous example of a tool that drove science forward is, of course, Galileo's use of a telescope to look at the stars. But I could give you many other examples of that, and this is something that is not really controversial. But this relationship between technology driving science instead of the other way around, or in addition to the other way around, I should say, is something of which you can find endless examples. And it clearly is what makes science progress. For instance, if you think about maybe what is one of the most important discoveries of all time, which is the germ theory of disease by Pasteur and Koch in the late 19th century, this was driven by a much improved microscope that was developed a few decades earlier by a man called Joseph Lister, the father of the famous doctor, who was a microscope enthusiast and who made the microscope much better so that Koch and Pasteur could do their work on bacteriology. Another example of a major technological breakthrough that drove science ahead is, of course, the discovery of the structure of DNA by Rosalind Franklin using crystal spectroscopy in 1953. This was one of the more important discoveries of all time, but it wouldn't have happened without that instrument. Now, today, we are actually looking at an arsenal of tools and instruments that dwarfs anything else we have had in the past. And everybody in this room who is working as a scientist knows this, of course, from their own experience. And really, we make the tools of the past look like toys by comparison. So just to mention a few, of course, we have high-powered computers that can do things, computations and simulations that we wouldn't have even dreamed about in the 1950s and 1960s. We have gene editing tools like CRISPR-Cas. which has just come to the fore in the last decade. We have lasers who have hundreds and hundreds and hundreds of very powerful scientific applications. And of course, knocking on the door right now is artificial intelligence. I'm still not 100% sure what it will do to the economy, but clearly what it is doing to science and to progress in scientific knowledge has already been well established. And this is true for almost every area of human inquiry, including my own in economics. And so what I am arguing basically is that there is a mutual co-evolution of science and technology, in which on the one hand, of course, scientific progress drives technology. I mean, there are certain inventions that you just couldn't make unless you really understood the science. I mean, nobody is going to discover building a nuclear reactor by accident, right? You have to know some nuclear physics. I mean, this is kind of obvious. But what is important to realize that, as I just argued, technology then feeds back into science. And the two basically constitute some kind of virtuous circle and positive feedback mechanism in which science drives technology and technology in turn drives science. Okay. Now, what we know about positive feedback mechanisms is that if the parameters are high enough, and I think in this case they are, this dynamic system will not converge. It will continue to change. And that, I think, is the reason why I think that even though the low-hanging fruits have been picked, science provides us with ladders to climb higher and higher in this tree of knowledge, to coin a phrase, and that we will continue to progress and advance in our scientific knowledge and the technological implications thereof. This system, as I said, may be dynamically not converging and therefore continue essentially forever. Now, is it the good news or the bad news? And that, in some sense, remains to be seen. The tools are powerful and becoming ever more powerful. But of course, with every advance in technology, there is the danger of its being used for salutary purposes to make us healthier or stronger or smarter, or they could be abused by repressive government, by evildoers of various kinds, by cyber criminals or other kind of criminals. I mean, this remains to be seen, whether making us more and more powerful technologically actually makes society a better place. I think that's something that's still a sort of concern for almost any observer from the outside. After all, institutions and politics don't seem to be nearly as progressive as technology and science. And so if these powerful tools fall into the wrong hands, this could be a source of major concern. The second question I want to raise very briefly is whether we actually should. It's not just whether we can, but whether we should. And there is today an ideology that many people adhere to, which basically says that we should no longer grow, we should no longer keep developing technology, and we have plenty of stuff to do, and we really need a society that's more equal, more just, more pleasant, and we should stop growing because growth is bad, because it ruins the environment, it creates inequality, it creates alienation, and on and on and on. And it is true that living standards, particularly in the West, are high. They are not everywhere in the world, I don't have to tell you. And so you could argue that even though maybe countries like Norway and the Netherlands and Luxembourg are rich enough and don't have to grow anymore, so I'm not arguing that, but some people could, that wouldn't be true for places like Cameroon and Niger. And so that's, I think, worth keeping in mind. But there are other reasons why we should keep growing, and I want to point them out very briefly because I think they point to the sort of fallacy of people who want to stop economic growth, particularly the kind of economic growth I was describing earlier, which is economic growth that is driven by technology. And one of them is, of course, dealing with climate change. I think much of the consequences of climate change are still not known. We're still learning this. There's a recent paper written by a colleague of mine, Diego Kenzig, which is now arguing that the costs of climate change have been vastly underestimated, and that they may be 4 or 5 times higher than the most pessimistic estimates that economists have come up with before. This still is an open debate. I think the last word has not been said about it. But the one thing that I think we can be absolutely certain about is that whatever happens to climate change, and however big it's going to be, it is going to be expensive, because we will have to adapt and adjust and change our infrastructure and our tools in a host of fields, all the way from water control to agriculture to perhaps experimenting with changing the atmosphere, for instance, carbon capture and things like that. Now, none of those things will be cheap. They will require more, not fewer resources. And economic growth, by definition, provides us with more resources. So if we do not continue to grow, our ability to cope with climate change, which is going to happen no matter where, in fact, it is happening right now, is going to be very limited. And the results may be quite devastating. And so we have to keep on growing. And it is only thanks to science and technology that we will be able to cope with this threat, because political solutions don't seem, sadly enough, to be on the horizon. There's a second reason, and that will be my final point, why we need to keep growing. And that is that in addition to climate change, the human race is facing a very serious threat through demography. We will observe a decline in growth rates in almost every economy in the world for the simple reason that the age structure of the population is changing, and the number of people in their more advanced ages who are not working is going to grow relative to the people who are still in the labor force. And that is not just a concern in Europe, where every nation is below replacement fertility, and in East Asia, but it will eventually spread to every nation in the world. Now, what that means is that we will need to use resources to pay for the care and the maintenance of people who are consuming but no longer work. That is to say, pensioners and old folk. And their medical expenses will be higher than the average person in the population, and very few of them will continue to work. I'm one of the people who continues to work, but I may be an exception there. And so there too, then, what we need is more growth, maybe different growth than we've had in the past, but more growth. Maybe not maybe, surely different growth. But we will need to develop the tools and the instruments, using robotics, using artificial intelligence, in order to take care of this ever-growing cohort of old people who are still around and who need medical care, who need a variety of forms of assistance and help. And whatever else happens, that too will be expensive, ladies and gentlemen. And so more, not less growth will be needed. And I think that that kind of growth can only be supplied by the continuing accumulation of useful knowledge, of the kind of knowledge that we discovered in the 17th and 18th century can drive economic growth and economic progress. Without that, the consequences may be very dire indeed. Thank you all very much. I hope you have a wonderful conference, and I wish you peace in this world. Thank you very much.
I first would like to thank the organizers, which give me the opportunity to talk in front of this distinguished audience, and in particular, my friend Roger Kornberg, who will allow me to talk about what I think is a big danger which is facing science today. I agree with most of what has been said before about science and the relationship between science today and the history of science, and you will see that I will make some remarks which are pertinent to that. We have to say that we live in a time of dazzling scientific progress. Quantum physics was born exactly 1 century ago, and it has revealed to us the secrets of the microscopic world. This knowledge has led to the invention of practical devices which surround ourselves in our everyday life and which has changed our lives. The lasers, the computer, the internet, magnetic resonance imaging, the GPS system, and I go on and on. Novel quantum technologies manipulating isolated real or artificial atoms are being developed now, announcing new ways to compute, to communicate, to simulate quantum matter, and to probe our environment with increased sensitivity and precision. Remarkable advances have also been made in chemistry, in biology and medicine. The development of new means of investigation that analyze, manipulate, or modify the genome, or study the properties of stem cells, announce the development of revolutionary new therapies to treat genetic diseases or cancer. Great strides are also being made in neurosciences. All these advances give us hope that science will be able to provide answers to the serious problems facing humankind, whether it's suppressing the causes or mitigating the effects of global warming, searching for new renewable and non-polluting sources of energy, or protecting us against pandemics through vaccination based on new scientific concepts. Many talks at the WLS meeting in the previous days have described these advances and the promises I hold for the future. The great paradox is that these successes of science are accompanied by a growing distrust of it in society. Science is under attack from the proliferation of fake news circulating on social networks. The irony is that these attacks are propagated by the extraordinary means of communication that science has made available to society, such as the internet and smartphones. The current development of artificial intelligence, which increases the means of manipulating minds, amplifies the potentially destructive power of these attacks. What is the explanation for this paradoxical situation? And here I think economy can give us an answer. The fast change of technologies we are experiencing today leaves a lot of people scared and worried about their future. Industrial revolutions destroy many businesses, replacing them by new ones requiring different skills. This is a theory of creative disruption elaborated by the Austrian economist Joseph Schumpeter about a century ago, at the time that quantum physics was discovered. And in fact, I think the 2025 Economy Prize is an elaboration on the early Schumpeter theory. To protect themselves, many people feel the necessity to react against the policies which have made this change possible, attributing them to obscure forces plotting against them. They share these conspiracy theories in internet communities which are cemented by a common belief in so-called alternative truths. Science is, of course, a threat to them because it aims at a universal truth based on rational thinking whose practice has the effect to gather all humans around a common set of values and not to separate them from each other. This story goes back to the origins of modern science at the time of the Enlightenment. It is in the period extending from the Renaissance to the 18th century that the scientific method was born in Europe. It was referred to Galileo in the previous talk, and I agree with that. This scientific method is based on the confrontation between the observation of nature and the construction of rational theories accounting for these observations. Philosophers, scientists, and mathematicians participated to the elaboration of this method, which has been adopted in the whole world today. Each new theory has to pass tests based on new experiments or observations which can either vindicate or invalidate it. In the course of time, Newton's laws have been replaced by Einstein's relativity and classical physics by quantum physics, quantum mechanics. This rational doubt, which always puts accepted knowledge to more and more severe scrutiny, is the opposite of the irrationality of conspiracy theories. The Enlightenment was also a revolution in politics, advocating for a society of educated citizens exercising freely their critical thinking. Nicolas Condorcet, a French mathematician, philosopher, and revolutionary of the 18th century, summarized the connection between science, politics, and education when he stated that any society that is not enlightened by philosophers is deceived by charlatans. Here the word philosopher stands for practitioner of natural philosophy, which can be science or humanities, as in the expression PhD for doctor in philosophy. What Condorcet meant is that free citizens must be well educated to be able to exercise their critical minds against demagogues. Condorcet's idea helped developing in Europe a public education system teaching to children the values of the Enlightenment. In Germany, Wilhelm von Humboldt founded the model of modern universities in which students are taught natural sciences and humanities together, developing their critical thinking, imagination, and creativity. This model was adopted by most academic institutions, first in Europe and in America, then across the world, notably in India and China. This universal system of education takes diverse forms in different parts of the world. The values of the Enlightenment were, after the collapse of the fascist and the Nazi rules in Europe and until now, fully respected in the Western world, while in Asia, especially in China, the academic institutions had to adapt to a different spirit. Confucius' philosophy, insisting on the values of obedience to family and political order, is at the root of an authoritarian political system which stresses the importance of education and of the development of science, but limits the freedom of speech. This is, in my view, an impediment to the development of the imagination and creativity, so important to think out of the box and make breakthroughs in knowledge. In spite of these differences, science seemed until a few years ago to be evolving in the right direction due to the sharing of the modern scientific method, to an open competition between institutions, and to a widely spread exchange of students, postdocs, and scientists across boundaries. Unfortunately, the situation is evolving today in a very worrying direction. The academic freedom is under attack in the USA, the land in which it was supposed to have the best protection. This unexpected blow is especially dangerous for science because this country, the USA, was up to now an example, a beacon leading the world in research and innovation. There is a high risk to see the same attacks happen in other countries, notably in Europe, with the rise to power of populist leaders. American universities are put under financial pressure to abide by rules decided by the current US administration, which attempts to forbid them to teach some topics and to control a so-called narrative, to rewrite history and to promote the teaching of non-scientifically validated theories. In a Texan university, for instance, a professor was recently forbidden to teach a course on Plato's banquet. This is an unprecedented censorship of Greek philosophy that seems irrelevant in my remarks about science, but as I said before, philosophy and science cannot be separated. Einstein, Bohr, Heisenberg, and Schrödinger were greatly influenced by the philosophical ideas of their times. An attempt to attack philosophy against philosophy is dangerous for science. The most worrying aspect of this new situation comes from a depraved usage of modern technology, and this brings us back to the connection between technology and economy. The huge progresses of high-power computers and high-speed communications has led to the modern internet and the development of big tech companies which exert a quasi-monopolistic power on social networks and media. This power will still increase with the progress of artificial intelligence, which can be the best or the worst of things, depending upon the way it is used. This point was already addressed earlier in this meeting. Now, the CEOs of these big tech companies have become incredibly wealthy, and they are now betraying the values of a science which has led them at the summit of their power. In an unexpected, dangerous move, they are advocating a version of freedom of speech on behalf of a libertarian, non-democratic vision of society. They ride the wave of the anti-intellectual resentment against political institutions and against college-educated people, which has led the current administration to power. They aim at creating a society in which they will have a super-state influence to dictate their will. These engineers of chaos, as they have been called by Giuliano D'Ampoli in a recent book, have set some simple missions for science, essentially to make them even richer and more powerful. Basic curiosity-driven knowledge is not their priority. For example, the administration which they support has considered to stop funding one of the 2 gravitational wave antennas of the LIGO project, which discovered gravitational waves, and we had a beautiful talk about that in the previous days, under the pretext that one antenna was enough, which is a complete scientific nonsense, as saying that one eye is enough to have a good sight. Health is not their priority either, as they have said nothing against the cancellation of programs helping to improve the access to health in the underdeveloped countries, and they side with an administration which puts in question the usefulness of vaccination programs in the USA. The welfare of the planet is no more their concern, since they support the withdrawal of the USA from the Paris Agreement about climate change and promote the increase of the production of fossil fuels everywhere. They are not troubled by the cancellation of surveys measuring the rise of temperature and of the ocean levels. On the other hand, they finance scientifically questionable projects such as space tourism for the wealthy, or the colonization of Mars, or the search for immortality, projects which are closer to their financial interest and personal hubris than to real science. At the international level, the situation is not better. The decisions made by the administration jeopardizes the collaboration on all kinds of scientific and cultural projects, as illustrated by the withdrawal of the USA from the UNESCO and from the WHO. More generally, the despise for the international order and the institutions which represent it have a negative impact on science. The geopolitical tensions are decreasing the exchanges of scientists between the West and the South. The pretext is to protect research in areas like quantum technologies, nuclear and AI research, considered as important for defense. But in fact, these restrictions also apply to basic science, abusively defined as strategically important. In the short term, China may benefit from these decisions, which primarily penalize American science, as illustrated by the recent surge of the Chinese universities in some world academic institution ratings. In the end, science in the whole world, including in China, will suffer. There is even a bigger danger that was discussed yesterday in the WLS meeting. The geopolitical chaos and the law of the strongest, which prevails today in Ukraine and in other parts of the world, including this one here, raise the specter of a nuclear war which might destroy civilization itself. What should we do to direct the world and science towards a more promising future? International collaboration should be reinforced, not weakened. Treaties limiting the use of nuclear weapons should be reactivated, as well as agreements about the ethical use of AI. The borders should open again, leaving scientists to communicate freely. And the big tech companies must be regulated to avoid their taking the financial and political control of the world. Europe, in which the scientific evolution was born, must play a more assertive role in world affairs and help to reverse this bad direction towards which science is heading today. This requires courage, wisdom and leadership, as well as a good knowledge of science by political leaders, and of course, more money injected into science to keep threatened projects alive while waiting for better times. Young scientists in particular should take an active part in the efforts to restore the values of science because they are the first to suffer from the current crisis. You may think that I am daydreaming by giving these kind of general solutions. I do believe, however, that we have motives for hope. The first reason resides in the check and balances of powers enshrined in the American Constitution, which is one of the great political legacies of the Enlightenment. Several American universities are asking judges and Congress to reassert their academic freedoms. What would be the immediate outcome of these steps is uncertain. Another hope comes from the length of time involved in basic research programs, which span long periods compared to the short electoral cycles of democracy. For example, the research of signs of life on exoplanet is a many decades long project which will hopefully survive the present chaotic time. It is a blue sky program driven by pure curiosity. Its goal is to increase our knowledge about the universe, even if no direct material rewards can be expected. We'll never go there. It is not a colonization project, it's just a blue sky project. Other projects of similar nature in astrophysics, particle physics, cosmology, or biology will hopefully be resilient enough to survive this difficult moment. At a time when fanaticism and violence are seeding death, destructions, and suffering in many parts of the world, the mere fact that there are scientists who continue to pursue the search of truth for its own sake, or keep fighting for the welfare of men and women everywhere in the planet, is an encouraging sign for the future of humanity. Thank you for your attention.